In today's episode we are going to finish the Amiga 500 Tower. Again, a project that took way more time than I expected. Should probably have taken the PiStorm stuff out and do its own series about that. But in this episode I will finally put the Amiga 500 into the tower and do a backplate and all that good stuff. So enjoy. I will first disassemble the Amiga, take out the drive, take out the board, switch the keyboard with a keyboard adapter and the 2000 board, and to get a step closer to putting this all into a tower. And here we are. So this gives us a pretty clear idea of how big the motherboard is and what we have to fit inside that tower case. The drive will be in a drive cage, I guess. Yeah, so this is pretty much it. I grabbed the case and did some test fitting, and this is a drive cage with a disk drive, which normally sits here. And as you can see, that board barely fits. So it still has the metal cover, which I plan to take off. It's still under here. You can see. And I wanted to do this like this, with the ports to the side. And you could say, hey, that works great. But the power supply has to go here. So doesn't work so great after all. I could use a smaller power supply, I could put the power supply somewhere else, but I guess it's a good idea to just mount the board like this. Can't mount it like this because here are all the connectors and I do not plan to solder on the board, but I'm planning on just putting plugs in here and extending this to the back of the tower case. So I have to turn this around. And that way I can also use RAM expansion and just put it in here. And all the connectors are on this side, so I can easily reach them. Here's enough room for a connector to plug in. That's pretty nice. That drive cage still fits perfectly. So this looks like a match made in heaven. There's absolutely no room on this side here. There's maybe a millimeter or so. And I have to find a way to actually mount the board in the case, because there are only a few screw holes and the board clips into the original case, but I have to come up with a solution to clip to this. So I will probably print an adapter board or two that connects to the underside of this case. Let me quickly show you. Because here are actually some mounting screw holes, and I will create some plates that screw in here and then put the screw holes on the other side to put the screws in there. So that is my plan for now. I have no idea if this works. We will see. Yeah, so that is the case. I'm not showing the complete case, and I'm not showing all the components around it. I have pretty much stripped this down to the bare metal case, so there will be a nice reveal in the end. Before I can finally fit the board inside the case, I have to take this metal shielding off, and this gives the board a little sturdiness, but it won't fit with this. So I have to take out all these screws here, and I will do that now. finally we have the board free. Now let me quickly put the screws back in so that we have something where the connectors can go against. Okay, I taped some pieces of paper together like that, and now I can create a template of the board. I will just quickly draw around this. And I will especially draw the holes so that I can make a template for my 3D printed adapter board that will go under this and screw into the board in the case. We will draw green circles around every hole so that in the next step we still know which hole belongs to the motherboard and which hole belongs to the case. So let's quickly cut this out. Okay, the case is back on the bench and we have these standoffs, and these can actually be moved. So you can just squeeze them together, put them somewhere else. That is pretty neat. Let me first get them all out. So what we do now is we use our paper template, put it in here, and check for these little holes in the case. And what we do is we need a pencil for that. I'm still missing the corner. Ah, there's one in the corner. Look at that. Oh, now it's moved. That's not good. Okay, I guess that's it. So here's our template. And now I need to design these template plates where we can screw the Amiga board in, and that then gets screwed into, oh no, first it gets screwed onto the bottom of the case, gives us these screw holes for the Amiga. On my template I did 3D print brackets. These look like that. That is number 3 here, number 2 here, number 1 here. I actually put in the numbers so that I know which one goes where. And the idea is that you can see these are a little raised here. You screw these down in the case, and then on top, because the screw head sits a little above the hole, you screw the Amiga board, and by that you should be able to mount this in this case without having any shorts. So let's try this out. And that does indeed seem to work. Nice. So I guess I will put some electrical tape over the screw heads. They are a little recessed in here, but I'm still not confident that that is enough. Just to make sure. I also printed some of these standoffs that I can just glue here with some double-sided tape, just to give it a little relief on this side, because there are no screws or something. So let's in the board and see how it works. Oh, that's really nice. Yeah, that should work. Very happy that this works. Now let's try to screw it in. Okay. Wow, that's really nice. It's a super snug fit, but it's all in there. So next we have to come up with a solution for the power supply. This is the power supply we will be using, and it has a lot of cables, most of which we will not be using. And this is an Chief Tech power supply from April 2014. So it's an ATX power supply, has this standard connector which delivers all the voltages we need to power an Amiga. And if we take a look at these diagrams here, I have these in two flavors. This is the Amiga side, this is the power supply side of the Amiga power supply. We have plus 5 volt, plus 12 volts and minus 12 volts and a ground. So this is just the opposite side. And if we check the ATX pinout, we see we have plus 5 volts, plus 12, plus 5 and minus 12. So all there's to do is to connect the right pins so that we could create such a connector. But I don't want to cut off the connector of my beloved power supply. So what to do? I guess we have to make one of these ourselves. And that will be interesting. I've never made a connector before. So yeah, let's check that out, I guess. And for that, I have nails. 4 nails. And my idea is to create my own connector, because these nails just fit nicely in here. And I'm not quite sure yet if I will 3D print something or find another way to just put the nails in the right positions and solder to these nails the wires of the power supply. Might seem a bit hacky, but in the end every connector is just a few pins inside a plastic casing, so why not do this and hot glue our own connector case around it. That should work, because these make nice contact. And yeah, I'm pretty confident this could work. Just have to make sure that you don't touch the different nails, because that would short them. So we will do some shrink wrapping around them, but can't see a problem there. Looks like a, let's not call it a great solution, but a valid solution at least. Okay, let's find a way to build this power connector. My idea is that I simply use a piece of cardboard. I put duct tape on both sides. And just like that I got kind of a base for my connector, which is sturdy enough. And then I just put in nails like this. And I have to cut this to size of the actual connector. And then put this in and put the nails in the right spots. Hot glue in the nails in the length of like this, so that they stay in place. And then connect wires, put on some heat shrink, and off we go. so much in theory. Let's see if we can pull this off. So we have to use four nails because shield is like ground, so we don't need that. And yeah, we have a middle nail already in. Let's try this out. Sounds like a crazy idea, but maybe it works. So here's the case again. There's the power connector, and what I want to do is to just put this on here, put in the nail, which goes about this deep, and then try to fit in all the other nails. I have no idea if this works. Let's try this out. Yeah, that's actually in there. Nice. Okay, so now we have to make sure that these nails don't touch. And then we get some hot glue and just keep them in place. Nice. Okay. Hot glue gun is fired up. Let's put some hot glue in there. Okay, that should be good. Okay, the hot glue has dried, so let's take the connector out. Yeah. Awesome. Can I get it back in? That is the real question. Yeah, it works like a charm. Awesome, awesome, awesome. Okay, so we can cut off some excess cardboard. And there's our connector. Very nice. Very, very nice. Yeah, just plugs in there. Okay, so now we have to clean off the top of the nails and give it a little bit room for some heat shrink to grab on. Most important part is that the nails actually stay in place. That is my connector. Okay, so let's get soldering, I guess. Right now I have 4 cables, 3 have the same length, 1 is longer, and the longer one will be ground, I guess. If there should be any chance that these grab to the nail, you really have to use all the resources we have at hand to do that. That means pre-tinning the nails, the cables, everything. Very nice. Now we go and put some flux on the nails so that these grab the solder. I've never soldered nails, so I have no idea if this even works. But right now, this looks like a pretty solid plan. Doesn't quite grab. Nope, doesn't grab at all. Oh, the only thing that happens is that the hot glue gets loose again and the nail gets pushed down. That is not cool. That is pretty much the opposite of what I wanted. Okay. So that plan is already fading a little, but I'm not giving up so fast. Just need a better plan. Okay, so here's the new plan. Wrap wires around the nails and then solder them, the wires to themselves, not to the nail because that won't work. And then we put on some heat shrink over that nail and then we are good to go. So that is pretty much all there is to it now, soldering these wires to themselves. We quickly do this and then we will see where we are at. And I'm aware that this is not the most elegant version of a connector you could do, but you can still go and buy one if you find one. But if you are like me and you have to quickly get a connector and you don't have one. That is one way to go. And we can put some more hot glue onto that once we have the heat shrinking on, because that would give all of this even more sturdiness, and that is a good thing in this case. That is my connector. There's ground, the longest wire. Here's +5, and this is -12, +12, -12, and +5 volts. Okay, I put some more hot glue on my construction here. I also put some heat shrink on top of that, so that I could in a minute just put this all together. So this is what this looks like now. Okay, let's quickly measure this, if it all still works, or if all the nails are connected. And then we can go and connect it to the actual power supply. So we put this in continuity mode. And then this should be the pin up here. Let's check. And it is very nice. Okay, so I guess we have a working connector. It's a bit hacky, but I'm sure it will do the job. In order to connect this power supply to our self-made connector, we have to take care of a few things. And the first would be that we need to check which voltages we need. And if we take a look at the Amiga output or input, then we see we need a +5 volts pin, which we can take from up here. We need a ground pin, which we can use ideally from here, because this is where the -12 volts is. And we need the +12. So there are all the voltages we need. And if we connect that, it should theoretically work, but an ATX power supply doesn't start just by flipping the switch. You have to connect the power on pin, number 14, which is the green cable, with ground. So we will do a permanent connection between those two pins, so that the power supply always powers on if we flick the switch to on. I'm also thinking about adding the power switch here. This might work. I'm not quite sure if you only have to shock it once or short it once, or if you have to keep it shorted. There's one more thing. You have to put some load on the power supply, or on most power supplies, because else they won't start. What we will do is we will use the built-in CD-ROM, which is not connected right now, and we will connect it to via the connector, so that it takes little load. I did the same for my Mister, which is in a normal case, desktop case with an ATX power supply. And yeah, that should pretty much do all the tricks we need. So there's plenty to do. I already opened up this cable sock to get to the cables, because as much as I like to do non-destructive stuff, this won't work in this case. We will cut some cables or some wires, but I wanted to have a little more room. This was here before, so that was very little to go by. And by cutting a cable here in this place, we can easily put it back together if we want to. According to our plan, we have to cut the green cable, which we will then connect with the ground cable next to it. Quickly check if this is the right cable. Yes, this is the right cable. So these two will be connected. Then we need plus 12, which is up here. And we need +5, which is up here. And we need -12, which is the blue wire. Nice, so that should give us all the wires we need, and we will just use these sides here, and we'll put some heat shrink tubing on this side so that we don't get any shorts. Good. So let's get soldering. I already did some preparation work, so I did put some heat shrink tubing on the ends of all the wires we need. I did also put some heat shrink around the ground and the power on wire, so that I know that these two belong together, and I cut another ground cable so that I don't have to build any bridges. So we have the blue wire, which is -12, and we have -12 on our connector, which is the short green wire. So this one here. So we will just put these together and solder these in a minute. Make sure to have heat shrink tubing on before, because else there will be no second chance. And then we have the yellow wire, which is +12 volts, and that is the blue wire on our connector. And again, we will solder these in a minute. Heat shrink tubing is on, which is very good. Then we have the gray wire, which is +5 volts, and that is the, quickly check, the red wire on the power supply. And that leaves us with the final wire, which is the black ground wire on the power supply, which is the long green wire in our case on our connector. And as always, before we solder, we put some fresh flux on it. Now, this should give us all the voltages we need on this power connector, and if this works, we can actually go and put it back in the tower and try if it works on the Amiga. But before we do that, we should probably check voltages. Okay, power supply is connected. Let's fire it up. Fan cam on, which is good, which means this thing is actually running. We should get some voltages, and if we connect with a multimeter, of course, these two pins up here, we should get our +12. And it's 11.8, which is good. Great. So this works actually. So let's put it back into the tower and give it more power. Okay, that's in. Then let's connect our homemade power supply and make sure that it's the right way around. I think this way. Okay, that's in. Just quickly want to show you how this is all wired up now. So there's our power connector, and there is our RGB out, which then goes into the TV. Here's our power supply. And I also did connect the disk drive, which worked perfectly from here to here, and the power from here to here. Yeah, so if we flick the switch now, that should work. What I will do next is I will connect the reset switch to these two clamps which go on the Gary, and for that I will remove that button and put on the reset switch header from the case. So that's what I'm going to do now. Which one goes where, as long as you use pin 1 over here. and pin 5. Always double check because you don't want these to be on the wrong pins. 1, 2, 3, 4, 5. Yep, that's correct. And just like that, our reset switch should work again. Let's power it on and see if it works. Machine is already powered on. There's kickstart, and let's push the reset switch. Yeah, works. Great. Okay, so we have power, we have reset, we have a working Amiga. Let's talk about that backplate which has to go here and all the port arrangements for a moment. As you can see, I have quite some issues here because there's this giant cap in the place or in the way. There's a chip and all that stuff, and to fit a backplate that has all the connectors on the backside was quite a challenge. And I couldn't make all the ports fit. If you have to, you can always use these slots, and there are a lot of these brackets readily available where are already cutouts for ports and stuff like that. So in the end, most of the Amiga ports are standard components like the serial port, the parallel port. I didn't bring these out. Yeah, so you can do that, just screw it in. I had to make a compromise because I want to have a USB port from the Pi, which is directly here, and I will bring this out here through one of these slots because it didn't fit in the backplate. So let's take the backplate and the process how I came up with it. So the first thing I did was to come up with something I call a fitting card, which is a very thin piece of 3D printed plastic which just has the ports cut out so that I could fit all of my connectors and stuff like that in here. And you can see this one almost fits, but the screw holes are a little bit wrong. So this was my very first attempt. Then came this, which is already an upgraded version. You can see one of the ports is bigger. This one is smaller because the cinch connector is a little smaller than expected. And when I had that and that worked, so all the ports had the right size, I went on to create a backplate, and you can see all these clearance things are okay. So here's this giant cap, here's this composite connector somewhere on the board. Yeah, and that had a few issues. So I came up with a version 2, and I already left in the connectors here. This is not the final product. You can see I redid the layout a little. I moved the audio connectors over here so that I had a little more room here, and I had to extend these two, and as you can see, these don't fit. The screws are a little nudged to the side, so I had to bring the screw hole to the side here. Had to make a little more clearance between these two ports. And version 3 is this one. And the layout pretty much stayed the same, but I did a little more nudging to the side. This went a little there and this little down. And I changed this Amiga to Amiga Tower. And I did some better writing because this, you can't see what this is, what this means. This was audio left, right, floppy, whatever, RGB. And I had to make bigger letters and yeah. So this should be the final product. So let's screw in the ports and see if it works. So this connector is by far the easiest because you just plug in the HDMI cable on the back side. No soldering required. Okay, that worked. Nice. First port in. Next we will do the audio ports. Not quite sure if left and right are color coded. I have to check this quickly. So apparently red is right. And why white or black, whatever color you have, is left. So we'll have to solder the wires to this one. And then we have the joystick ports, which are still in here, so I have to unscrew these. Took me quite some time to get to this point that everything fits nicely in here. Next up is the keyboard connector. I guess I will go this way around. Okay, so all that's left is the RGB connector and the floppy connector. And I do have the floppy connector here, but I have to desolder all these wires here. Okay, I guess I will leave it like this for now, and let's try to fit it into the case. But before I do that, let me quickly change this one here, which is a Firewire connector slot, and I will put my USB port in here because it has exactly the same footprint. And this simply connects to the Pi, so that I have at least one USB port present if I ever need to put in a USB keyboard or something. I want to connect some media to the Pi, like a USB stick or anything like this. Let's first put in this USB slot. Nice, that's in there. There's our USB port. Oh, that fits perfectly. Guess we have to do some hot gluing here, because even though it's in there, I'm not quite sure if it will hold if we push against it, but that looks awesome. So this is a very clean build. I'm very pleased with this. Let's take a look inside. You can see that all the clearance is pretty much spot on here. That should work. Nice. Keyboard connector has the right length, so it can plug in here. Also great. Yeah, I quite like this. Okay, I did solder in the audio connection, and I did put in the floppy connector. I'm not using an external floppy right now, so I will leave this blank for now. By the way, I got this from an RGB to VGA adapter, and that cost about 10 euros, and you get the right port. But there's a different problem. That is, these connectors for RGB and floppy are very hard to come by. And you can see this is my SCART cable, which someone sold me. And they did indeed cut a larger connector, which is the parallel connector from a no, it's a serial connector from a standard serial cable, and this is a parallel cable from, or a parallel connector from one of these Centronics cables, which are very easy to come by. I have a whole box of these, and I just desoldered the parallel port connector, and you can plug the smaller into the larger, so that's good. And you can also, and I did this right here, remove the outer two pins with some pliers. You can just pull them out, and then you get a perfect connector, and that will then go in here. But I will have to make this hole a little bigger, because I did calculate on using this one, and that won't work. So no problem here. But just so you know, you can use a parallel and a serial connector and just make them bigger or smaller, just the way you need. And he did some sawing here. He sawed off the outermost two pins and then put some, I guess this is epoxy or something, on here to seal the wound, so to say. And I might do the same for my connector, because I have to plug the other end of this cable, which is the extender for the RGB, into the Amiga, and that won't fit the larger connector. So I have to go the saw-off route, I guess, because I don't have these connectors. So I did source one of these connectors, and I already removed these two pins because we are not using these. And I just did the same as with my RGB connector, and I'm going to saw off these two pins, and then I will put some epoxy or something on there, and then we'll have a nice little RGB connector. So before I go on and solder in these two joystick ports, I wanted to quickly show you the RGB connection. I opted for a simple rainbow cable set. This is my self-made connector, which fits perfectly. And I only soldered the cables that are needed to make an RGB SCART connection. So this is not a fully connected cable. It's just, I guess, 7 or 8 cables. 2, 4, 6 cables only. So that made it way easier to build this. So now I have to finish these two joystick ports, and then I'm going to put it all in the tower. I just noticed that we still have the issue with the power LED, which is not connected, and I want to connect this. And for that we can use the second pin from the right on the keyboard connector, and we will have to solder this one to the ground of the keyboard connector, which is already on my backplate. So this will go on that gray wire here, and that plugs in there, and then we should have power LED. So pin 6 on this connector is indeed ground, so we will just cut this here, and then we will go and grab that gray wire and twist this up here. For now I will just quickly do this without soldering until I know that it really works, and that should do the trick. Okay, so let's finish these joystick ports, put it all in, and see if it works. Okay, first test with the running machine, and everything seems to work. Most importantly, the RGB connection, which only has 7 wires, so this looks awesome. Very happy. And yeah, even the power LED works. That's great. So let's finish this up, and I see you on the other side with the finished product. So here's the finished Amiga 500 Tower. And this is the original A500 disk drive, which I designed a 3D printed plate for. You can find the link in the description below. I added this little Amiga sticker before there was the high screen logo. And I think this came out very, very nicely. So let's check out the back. So right now I have no HDMI connected, and also no USB. I had to move the USB port to the lowest slot because the cable wasn't long enough. But as you can see, everything looks very clean, and that was exactly what I was going for. The A2000 keyboard is connected, and the mouse and the monitor, and that is it. And it boots lightning fast from the PiStorm hard drive. Here it is, the A500 Tower. I'm pretty pleased with this actually, because it just the board just fitted perfectly into this case, and that was more by accident than by planning, because I didn't plan this before. There are a few things I would add. Maybe there will be a part 5 somewhere on the horizon. One thing is to actually have a power button in front of the case, using the case button here, to connect the CD-ROM drive, to maybe add a Gotek drive down here. And that can be done very nicely, because we can actually do the connection inside the case with one of these second drive interfaces. I did actually print one of these brackets for the disk drive. I guess I didn't tell that in the video. I designed that specifically for the A500 drive, so you can just put this in here and glue it in, or I have a second one which is even a bit taller up here, so it sticks in. I also 3D printed this and then painted it in the case color of the A500 case that I had lying around, so that fits even better, even also from the color. Yeah, there is a lot you can do with this case, and you can even do more expansions on this thing. But for now, this project is good for me. I will use this. It's a really nice tower, and it's just the way I expected it to be, and it's just what I would have loved as a kid. So pretty pleased. Tell me what you would do with this case or with this project. What would you add? What would you change? Would you do anything differently? Let me know in the comments. And if you want the models for the drive plate, for the backplate, and for the mounting mechanism to mount the board inside the case, see the link in the description below. There are all the STL files you could ever want. Yes, this is the A500 Tower. Thanks for watching, and until next time. Bye-bye.
Thank you for watching Retro is the New Black. If you're new to the channel, please like and subscribe. If you like the video, please share. Every like, share, and comment helps a lot. Until next time, bye-bye.